All right, let's get started. So, the topic of today was going to be servers. Maybe we'll do a little bit of that. But I got a good question after class. What's going on with this NC? And like, what were you doing on the terminal there? I didn't get it. And so, I think maybe we'll back off a little bit, and then on the way over here, I got this brilliant idea. Why don't we implement NC and see what it does? Right? So we'll see. Maybe we don't get all of it, but I was pulling some tricks there. Let's just do that again. I've never really explained NC, I suppose, or this telnet thing that we're doing. So maybe we should start with the basics then. So if I go to if I use telnet, all it does is it takes input from the terminal. It waits for a new line. When it gets a new line, it sends that to the other end. Right? So if I'm connecting here to google.com, actually, I think they want www.google.com 80. Oh, that doesn't actually matter. Here it doesn't matter, and you'll know why in CS450. But so now all it did was create a socket with connect, or with socket, and then connect it to this address with connect. And now it's waiting for me to say something. So I'll type in get HTTP 1.0, and then maybe I have to tell it the host here. I think that should do it. So what happened here? Well, once I hit enter there. Actually, once I hit enter here, telnet, the program, it's a very simple program, read that line and did a write to the socket, or a send. It's actually the same thing, really. Write or send to that socket file descriptor. And then I did it again. So now the server, it got the first thing, but it figured, okay, that's not enough, because the protocol says there has to be an empty line. So with HTTP, you got to have an empty line after your request, and then begins the response. Okay, so now I type some more. I hit enter, and again, it only does it line by line. So now the at least that's by default. You know, I'm not sure actually. No, I'll take that back. I don't think telnet does that line by line. I think it doesn't really care. It'll send after a few characters, whenever, after some time, it'll just send things. But the server still doesn't do anything because it didn't see a new line, it didn't see an empty line, so it's just receiving these bytes slowly. Okay, so, but now I hit enter twice, so the server now has received an empty line, and then it responds. So every HTTP response begins with this line. Here it says 200, anything in the 200 family, 201, 202, and so on, they're all saying, okay, that's fine. This is a correct response. You might have a 300, and that says it's a redirect. So we didn't actually have quite the right address. It wants us to go somewhere else. If you type in google.com here, it'll do that instead. It's a 400. You've all seen the 404s. That means the document isn't there, but there's other 400s, and then there's 500s, server error kind of things, where there's some software problem on the server. Okay, so anyway, so now that's the HTTP response, and then there's an empty line here again. And then finally, there's the actual document coming out. Wow. They really make it messy. Okay. So that's telnet. All telnet does really connect and then give you, or whatever you type in, send that to the server. Whatever the server sends, put it out on the terminal. And that's really the same thing with NC. But maybe we can actually try this. We'll try doing the same thing with NC. Let's see. Would that work? Maybe. So NC does the same thing. It takes whatever comes in on whatever parameters you say. It connects to a socket to that server, and then it reads from standard in. Actually, we shouldn't have to say cat even. I can maybe even go like that. It reads from standard in, and then whatever comes from the server, it writes on standard out. Let's see what happens when I just do like that. So now I'm connected to the server, do the same thing. I've never done this before, so let's see if I'm missing something here. Oh no. Okay, same story. So maybe one slight difference here. The server closed the connection here. In this case, actually, I don't know what the difference would be. I can't think of a really good difference right now, but Telnet tends to be used if you want to do a remote interactive login sort of thing. NC you tend to use for scripty stuff, for one-liners, that sort of thing. Now I'm a little confused what the actual difference is. Anyway, so that's one aspect of NC, but NC can also be a server. Telnet can't be a server. So let's try that. So now NC does the same thing if I'm a server. Now I just say I want to listen to this port here. So L for listen. So now I'm listening to port 7890, and so then I can connect to the local machine with another one, 7890. So this is the server, here's the client, and again the server is going to just be reading from the standard in and writing it to the socket, but there's no socket there yet, because no one's connected. So once it gets connected, we should be good. So let's connect. Right. So now this program finished. NC read from the echo here and wrote it to the socket. On the other end, we connected and we read from the socket and got the output over here. So I guess there's one more piece there. Why did it stop? Anyone? Like, why is this not by just waiting for more input?
We just echoed hello. That's it.
Yeah, so what NC does, it looks at the output from here. Actually, let's do one more thing here. Let's be a server again. But I don't do the echo hello. So now I'm not redirecting standard in, right? Now I got the regular standard in here, over here. So now we'll connect again. Alright. Okay, so there's no, yep.
This is a little off. Is this what the screen utility does on Unix?
Absolutely not. No, screen is something completely different.
It just seems similar.
But it's awesome.
Okay, screen is great. Yeah.
You can use screen to do something that looks a little bit like this. You're thinking about mirrored screens, perhaps? Screen is usually just used to preserve a session on the server.
Oh, okay.
Right? But it can be handy for sharing a screen, too. Sharing a screen. Very good. Okay, so anyway. See, this hasn't finished yet. How do we get it to finish?
Control D.
Control D. What does that mean?
And say, we don't send anything.
Control D enters the character end of file. Basically, but that's not really a character, I think. No, it just says the terminal here. Whoever's controlling the standard in, which would be this window here, the program that runs this window, it'll just close the file descriptor that is standard in for NC, for this NC here. So if I hit Control D, we close that file. Right. Now I do that. Okay, so NC sees, okay, the input was closed. There's no more input ever to be received from this standard in. So in that case, I'll just go ahead and close the socket, because the server needs to know that there's no more coming. And when the server, or actually it's the opposite, the client here. So when the client sees that there's nothing more coming, it'll just quit.
So Control D looks at NC and sees what file descriptor is responsible for the input?
No. So when I'm running NC here, even if I'm running cat and NC are very similar. Right? Cat has a standard in. Where does that come from? It came from the process that started cat. Right? You fork, bash here is forking and then suiciding and becoming cat. Right?
Oh, yeah.
But that's standard in. Where did that come from? Maybe from another bash, who knows? But at some point, it came from the windowing system here. So at some point, it's the program that makes the picture that is controlling the standard in.
program that makes the picture.
This picture here, this whole picture,
Oh.
right? It's got to come up there somehow. And so that program is, so when I type a J, right, it's actually this window program here that receives the J, and then it says, okay, but I promised this guy who's running inside that I'm going to provide all my input to them, so then that goes in that standard in, and then maybe that process then forks, and so on when the standard ins get propagated. But at some point, I hit Control D, hello, and then it's all over. Okay. So NC doesn't look that complicated, but there's a couple pieces there that are interesting. So first, we haven't still finished our server, right? So we'll do a server, but then the other part is you're not just receiving or just sending on your NC. There's both options here. So if you think about this, you have a if you call receive, what happens? If there's no input, you just wait, right? Call receive on some socket, you just sit there. So what if the user types some and they want to send that? You're still just waiting, so you're not able to receive that stuff from the user. So that becomes a problem, right? So now we have two file descriptors, and we don't know on which one the action is going to be next. So we want to either read from the standard in to try to get the text there, or read from the socket to get whatever's coming from there. We don't know which one's coming next. What do? Non-blocking sockets. Okay, so that's an option. So you can actually set a little option on the socket so that it'll read. You call read or receive, but if there's nothing there, it just returns right away. How does that sound? If there's something there, of course you get it in your buffer. Not bad. It was your idea, right? Yeah. So anyone else?
Use the wait gate to fork process. You just tell what the wait was done.
Oh, I see. So you fork the process and you wait on one in file descriptor in one process and wait on the other file descriptor in the other process, and then you wait for both of those in the parent. Is that the idea? Sort of? Okay, yeah, maybe it's doable. Seems a little complex.
That's probably a terrible idea. You could probably pack them both in.
Put them both in one?
Yeah.
I don't know how you would do that, actually. So I don't know how you would merge two file descriptors without actually running some code. Doesn't work. No, so I'm looking for a problem with Ian's solution here.
Yeah, so how do you get back to listening again?
Oh, that's okay. So you call receive and it immediately comes back, no, there's nothing there. And then you call or read. You read on the standard in, and immediately says there's nothing there. Sounds pretty solid, right? But there's a problem with it. What are you going to do next? Okay, but so we don't have to do anything actually. We're in C, we're just sitting here. So we're going to call receive on one, call receive on the other, loop around. Do it again. Just do it like that. Okay. Any thoughts on why this might be bad? The program is doing nothing, but it's running at full tilt, right? Calling these receive functions all the time to see if there's anything coming. Draining your battery, making the fan go, making all the other programs run slow.
At least you don't have to worry about your processor idling away at CPU.
That's true, yeah, you don't want to waste those cycles. Yeah. Threading, yeah, that's an option. So if you're threading, now you could have two, and we'll maybe not have time to do threads today, but this is the same as with the forks. So you could have two blocking reads going on at the same time. But now you have this other coordination problem. What do you do after this?
Imagine if you have a big web server comments read that many times.
Yeah, so all of this is a little difficult without one more function that we haven't talked about yet. And so hopefully we'll get to that toward the end of class. Actually, you get to use it. The last one here, the all important select. Okay, so with select you can pass it a few sockets, sorry, a few file descriptors, and you say, okay, I want to see if anything comes in on any of these, or if one of those becomes writable, or if there's some error on one of these. And I want to wait for this long, and you can wait forever if you want. You can wait for a certain amount of time. So with this, if we have this magical select here, now we just say, okay, I want to wait for these two, and select will return when one of them has some action on it, and it'll tell us which one had some action. And then we can go and read, and that read will be non-blocking. We get something right away. So that's actually something we have to do in NC to make NC work. So that seems like a pretty good practice run then. But let's first get this server back. So I looked into this, and I don't know if I forgot or if I somehow always had it wrong. But there was definitely a screw up here. This listen does not block. So we had that over here. Wait for incoming request. That's actually completely wrong. So this is, let's say, register willingness to accept incoming requests. Okay, or incoming connections, really. I must admit I am a little bewildered why it's like this, but I have a theory why it works like in this particular way. So why do we have this extra call here? If you bind already, isn't that fine? Right? You think that, okay, so now we're connecting, now we're saying, oh, this is my port and so on. So what's the big deal? Why do we need to have a listen as well and then an accept? It seems a little over the top.
Which is set up as a read-only server. Is that accepting traffic when it's only?
Oh, well, so these are not accepting like requests. They're accepting like connection requests.
Right.
So it makes a connection, and you can never make a server that doesn't accept such connections. That doesn't make any sense.
I feel like the file permission thing on a more local level is like a file permission sort of idea.
Oh, maybe. So anyway, my sort of half-baked theory here is that, well, I know that bind is not just for servers. If you want, if you're a client, you can also bind. You say, my outgoing packets should be stamped with this origin address and this origin port. And you can choose whichever you want. Now, usually you don't bind, and the OS will pick one for you, a random port. But you can, if you want, say, okay, I want this specific port. It usually isn't relevant, but if you're under very specific circumstances, it might make sense. On a browser, it wouldn't help. That's for where you're going to. Browsers almost always have a random source port.
Because we're talking about why there is listen in between bind and accept.
Yeah. So
But wouldn't we want to kind of wait until we get the connection to actually accept it?
but that's the problem. Listen doesn't block. So I always thought that listen blocks. For some reason, I totally had this wrong. It doesn't block. So all you do is you get to specify here backlog. So you get to say which socket, and then a backlog. So the only real thing here is that when you bind, that doesn't say anything about if you're a server or a client. So now when you declare listen, that means you're a server. It doesn't mean you're ready to take a socket right now. It just means you're a server. So now the OS should start backlogging connections for you. If connections come in before you're ready to start accepting, that's fine. The OS should just hold on to them for a little while. So that's the only little subtlety I can see. You could also just say accept right away, but then you might, I don't know where you're going to get the backlogging. So.
But I wonder if we were using this direct serial port connections, do we have to use listen for those?
Oh, serial connections don't use sockets. They're just they're little device files. In the /dev you might see that. We'll deal with that in 385 as well. But they look more like a disk than they look like a socket. Because you can't connect them to other places. They're always in one place.
server flag.
Oh, I see. Yeah. Well. It's possible. It's actually possible to make connections between two clients and not have a server. If both of them at the same time say connect like this, and both of them are bound to the right port, then it actually works. But that's really something you would never do. It's just a strange quirk of the TCP standard. So anyway, now that we've clarified that, we want to say we're a server, and now we're accepting an incoming connection. Okay, so what does this accept do? It gives us a new file descriptor. So we'll call this client sock, perhaps. Okay, so let's repeat that part here. So we're making a socket here. Maybe I should rename my S's to server S, server sock, just to be. So here's our server sock. This, bind it to the right address. Say we're a server. Ask the OS to start buffering connections, that is. And then we want to accept the first incoming connection on this server socket. So this is again, this is a little bit tricky here, right? We're not going to be talking to whoever connected on the server socket. The server socket is only there for listening for incoming connections. Then whenever we call accept, we get a new socket. So now we have two file descriptors. Actually, we have 5, right? We have the standard in, standard out, standard error, and now we got a server socket that we created. And finally, when we call accept, we get a 5th one, the client socket. The client socket is the one that's connected to the other end. Okay, so now let's read something. Oh, this looks pretty good. So we'll receive that, and then I'll just write this to what? Standard out. So now I'm being very low level here. I think it might be helpful later on. Okay, so we got a connection. We accepting the connection. This server is a strange server. It just receives some instructions and it prints that out on the local standard out. Okay, that's probably not a very handy server, but let's do it that way for now.
What's the apps that you're sending and receiving?
Let's see. Oh, S. Yeah, that's. I'm very confused here. This should be a client sock, and that should be buff.
And send as well.
Is there a send? Oh yeah, this is just comments. Let's get rid of those.
Sorry.
We'll keep them for later. We might want some of these, so I don't have to type everything. Okay, right. So we got our socket, and now we're receiving from the socket into the buffer at most 10,000 bytes. Okay, that looks good. Okay, I'm gonna fix that as well.
19, there's an error.
Yeah, thank you. What are we upset about at 19? Ah, an extra parenthesis. We need more includes. Getting pretty close. What's this? Oh, I see. So bind, it actually wants a certain type of pointer. It's not a sock adder IN. So this bind and the whole socket interface is not only for internet sockets. It's for any sort of socket, and these days you only use internet sockets really. There's at least one called Unix domain sockets that are also still in use, and they use the same API. So this IN here indicates that, oh, this is a sock address for the internet. You could have a sock adder underscore Unix, I think it is, or any other thing you want to come up with. But bind then wants sock adder pointer like that. So let's get that warning out of the way too. And what are we missing? What? Oh, it's a directory called server. It doesn't want to overwrite my directory with a file. That's fair enough. Okay. So we're okay. So this error here, we were printing something here. That there isn't an error, right? Undefined error 0. 0 is not an error. Let's get rid of that. Trying to be a little extra clean this time, so we're not getting too confused. Which port is it? 8080. So let's talk to that machine. We're connected. Hello. Okay, there we are. Okay, so there's our server. What if we wanted to... why did it quit? Any ideas?
We just received one.
Yeah, but I didn't tell it to quit here. Connection closed by foreign host. It was that one that quit on us. What's up with that?
Shut down, so it said I'm not doing any more.
Yeah, so it didn't wait for me to finish typing. I typed in hello, right? But I wanted to send another message. I want to say how are you, right? But then that's very rude, exactly. So what happened here was receive got a little bit of a message. It got the hello, and then this program is kind of eager. It doesn't do much more. So receive will always, whenever it gets a message, it'll be a little packet. Whatever Telnet decided to send, and in this case it did decide to send when I hit enter. That was pretty clear. Let's do it one more time. See, nothing's happening. All right, and now I hit enter. Okay, so it clearly only sends anything when it hits, when I hit enter. Okay, so now we received our message, we write it out, and then the program is done. So what happens when a program dies is the OS is going to close all of its file descriptors. And if the file descriptor happens to represent a socket, it'll close the socket, which means it'll send the other end a message saying, okay, I'm done. And of course, Telnet, knowing that the other end is done, there's no point in continuing running, so it just finishes. So if we want to fix this, why don't we go like this. Okay, so this is a kind of a hacky way of doing things like that's standard to do in C, right? So I'm saying now this actually means while this receive thing is not 0, while it doesn't return 0. In that case, right. So every time it doesn't return 0, right. But of course it'll block, receive blocks every time. So let's try this again. Very good. Okay. All right. So now, if I want to close this, what do? I have two options. Either I can kill it here. How would I do that? Control C. Yeah. Control D is not going to do much because there's not. It doesn't care about that. It's not waiting for standard in. It's waiting for my my socket here. Okay, but. So over there I would have to say Control C to kill the program. And over here? New line doesn't do it. Oh, look at that. Okay, Control D would be good, yeah. Control D, Telnet would know how to deal with that. All right, Telnet knows when my standard in is closed, then let's quit. I think, although I'm not 100% sure, I think that the standard in is closed here too, for my program. My program doesn't write out the stuff that I'm typing. It's something else that's writing that out. I'll have to figure that out, really, what's going on here. My program certainly is not writing anything to the screen, right? I'm typing on the screen, but my program is not involved. So I think the standard in is closed for my program. But what happened there? What's up with this?
start with W.
What's that? So we had a how are you, and then I called receive, and what was in there?
It has something to do with when you press the control keys.
I don't think it has to do with the control D. We're not reading from the standard in, so the control Ds are on standard in over here.
Right.
It's something that happened over here. Look at this. It's hard for you to tell, but let me do it here. I just hit enter once. Oh, wrong side. Here, I hit enter once on the telnet side. I do it one more time. Huh?
Oh God.
This is overwriting.
So
Oh, the buffers doesn't contain the new line.
exactly.
Different for the servers.
So this buffer here, we just keep overriding the buffer. And I'm sending it. Now I sent how many characters? 5? At least 6. There's a new line in there. It's actually one more. There's a \r\n. It's the new line in this terminal. So up here, it became \r. The buffer now became \r\n wru. Right? So here's the \r\n, and then the rest. So when is this write gonna finish?
Unless you write something that's longer.
It'll continue for this many bytes. How many bytes is that? 10,000? How does Stirling buff know how long buff is? Exactly, yeah. So Stirling doesn't know anything about the type of buff here. There's only one thing, it's like, what is it? Sizeof. Sizeof knows about the typing, because that's not actually a C, that's not a function, that's like a C built-in primitive. Stirling is just a function. It is going to start at buff and run along until it finds a 0. So there was no 0 to be found until a little bit later. So for some reason there were some zeros in there. We got lucky. It was actually full of zeros. But then we filled in a little bit with this how are you stuff. But at the end there's zeros. So I guess the lesson here is Telnet didn't send a 0. Because Telnet didn't send a 0, it doesn't care. These are not separate strings to Telnet. This is just bytes coming in. Because it didn't send any 0, there's no 0 terminating the new string that I typed in. So it'll just treat the whole thing as some big overwritten piece of junk. Okay, so I can't actually make Telnet send the 0. Yep. So repeat the sentence. Well, what do you want me to write? See, so now we'll try a long one, right? So that gets in there, and then we'll say bye. Okay, so see what happened there? We had a whole sentence, and then there's like 10,000 zeros after, and now we replace the now space W with by \r\n, and then we had the rest of the code until we hit the 0. Okay. So if we wanted to work right, this might be reasonable. Set buff 0 10,000. Right. So this one's just clearing it out now. That might be a reasonable way to do it. Okay. So we have our server, but it's not able to send anything yet. We can just receive. A receiving server is kind of silly. I suppose we could go ahead and write something. Hey, why did I put 1 here? instead of standard out? Standard out is not an integer. Standard out is a file pointer. There's a, I can say the same thing. I can go like this: file no standard out, and that returns a 1. Okay. But now we wanted to write to our client sock. Welcome. All right. And then we need a length. How long is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's try that too. Ah.
Uh-oh.
Uh-oh. What happened there?
You didn't actually get it fully finished in the socket still.
It's still balanced in the port.
The process is dead.
So the OS should close the
Yeah. I always should have closed it. This is too tricky. There's a thing in, and we'll talk about that in detail in 450. There's some problem with reusing the same port. If you run one program on a certain port, and then you run another program with the same port soon thereafter. The second program could be unlucky and receive a stray packet that was meant for the first program. So then you'll get all sorts of confusion there. So by default, you're not allowed to use the same port within a certain time. Okay? So I think maybe now we're allowed to use it.
TCP handles that?
TCP handles that for you. But there's a socket option that we can set to tell it, I don't care. It's called reuse adder. We'll probably have to do that because, well, we keep reusing the same port all the time. Okay. There we are. Stuff. Welcome. And then we'll close. Oh. Oh. Oh, yeah. I can't close in... Sorry. This is Telnet. If this was NC, it would know about Control D. Now it's actually sending a Control D over to that side. And that doesn't mean anything. So I need to tell Telnet to close this. And it's not Control D in Telnet. With NC, if this was NC, it would be Control D. So for Telnet, you have to go, and this is a little confusing. It's like Control right square bracket. And then you're on the Telnet command line, and then you tell it close. And there it is. Okay. So just to get that all sorted out, let's do one more. Oh, look. Now it didn't mind. It must be a very short time period there. Different OSs have different requirements on the time period. Let's try it with NC2. Welcome. Control D. Ding. Okay. There we go. Okay, so we're not done though, because now we want to be able to, on the socket, we want to be able to not just send a default message like that. Whatever is typed in there should end up over here, right? So far, whatever we type here ends up over there. That's great. And whatever the server sends is going to end up here because Telnet is doing this for us. Telnet already knows how to connect to someone and receive and type at the same time. But now we want to do the same thing. So our server has to be able to read from the standard in and read from the socket at the same time and output the two different directions. So that brings us to select. So let's write this select server. Okay. Hello. Okay. There it is. So a select server, we need to include one more thing. Sys-select. So, as I said, with select we are able to listen on more than one socket at the same time. We're not able to receive on more than one socket at a time, but we can just ask the OS to tell us when something's going on. Okay, so the while loop here, this is going to have to move a little bit. And we'll just say while select something or other here. We haven't really decided what yet. So select is going to block it until something happens. And then we'll receive. And right now we're just receiving from the client sock. That's maybe not the best. We'll have to improve that too. But first we need a way to tell select which sockets are we actually interested in. Or which file descriptors. So the way that works is you allocate an FD set. It's a file descriptor set. I'll call it our read set. And then it's, how does it go? I have a little reference for me here. Oh yes, good. That's actually wrong. It's FD set like this. Right. So now I'll have to say FD set. This is a macro here. So now I'll say in my read set, we want to enable client sock. Okay. So now I'm able to read from. Well, I'm telling select that. Okay, we want to listen just to this client sock. Maybe there's something more. Oh yeah, we want to initialize it. Okay, if I didn't initialize it, it might not be a 0. Everything would be very confusing. This here is just like it's just an int. It's treated as a bit array. So, so we need to initialize it, and then we say, okay, number 5 here. We want to listen to that one, and let's just go with that one for now. So that will be enough. Now we can say read set, and I'm not interested in. Okay, maybe it goes one more here. It's something like the size of the. Let's do a man page for this. Oh, yeah, number of file descriptors, something. I'm actually not quite sure, but that should be sufficient at least. And then we'll say, so this is the read. Which sockets do we want to read from? This says which sockets we want to write to. Which sockets are we interested in listening for errors at? And then for how long should we wait? So I'm not going to have a wait period, which means it'll wait forever. Okay, so now let's put in something here. Something happened. Okay, what's up? 28. Oh. Read set client sock. Oh, went the wrong order. Okay. Okay, so it seems to do the same thing so far. We're connecting. Actually, it wasn't even at the select yet. We were at accept for a while until I connected, and then we continue. So now we did these things, and now we're at the select waiting. So now, as soon as I send the message, something happened, right? And that's what I sent. Okay, good start. But now we want to listen to one more here. So we'll just say standard in. All right, so let's give that a shot. If we can just get it to, this is going to get weird, but let's do it anyway. Oh, maybe we should do that address reuse too. See if I have that somewhere. No, I don't. Okay, set sock up here. Right. So what we want is
Reuse
reuse port, I think. Reuse adder. That's the one I've seen most of the time, but port looks like it's more relevant. Anyway, so let's just do that. So we'll say here, before we try to bind, set sock opt server sock. What do we have here? Level sol socket. Use adder, and we want a value. It's a pointer to a value, so let's call it. What is it? It's a option value. Call it on. I think it goes like this. And then, how long is it? Actually, we can probably go with 0, 0. Let's try that first. Because we're not really passing in. We're just saying, okay, we want to be reusing addresses here. So let's try that out. Okay, so now we're connected again. We're at that select. So now if I type something on this here, this command line, something should be happening. Ah, all right. So now we got a receive. We got something is readable. What happens now? Actually, anyone? If I type again here, what's going to happen now? Scroll down here so we can see the code. If I hit enter here, what's going to happen? Oh. We are currently blocking on this line. Nothing's going to happen. All right? So select said, okay, yeah, something happened. All right? On one of these two sockets, something happened. And we start reading from the wrong one, from client socket. And of course, this receive here is taking forever. So if I now type something in here, hello, now something happened. And now we're both waiting. Oh, now it actually probably got this H here. Yeah. So now we were waiting for, let's do this a couple more times. In fact, there's always something. Okay, anyway, that's not a good example. So now we need to figure out which one actually had something happen on it. Right? So we read from the right one. Let's try that out before we go. So for that we have another macro called fd_isSet. If fd_isSet, which one goes first? Let's check the man page. fd_isSet, our file descriptor, and then the fd_set. Okay. So now if standard in is set read set, then we'll do it for standard in. Actually, let's just do it like this, because we're a little short on time. And otherwise, we'll just do this. Okay. And this doesn't make any sense anymore, so I'll get rid of that. Okay. So now we're saying, okay, if the bit is set for standard in this read set, that means select is telling us, oh, there's something going on that set. Okay, sorry, on that socket. So let's try that. Oh, wrong. There. Oh. Oh yeah. Okay. Thank you. Okay, so let's try this. Now both of them are connected. And now I'll say stuff here. Whoa! Okay. So, final lesson here. What's going on there? Echo? No.
Oh, we have to flush clearing the.
We never read it. Right? So select says, oh, there's something there to read from standard in. Okay, so we ignore that and we go around and ask if there's something to read from standard in. It says yes. Okay, so our NC isn't quite done, but we're pretty close. I think we only have a few more minutes, so we'll do that next time. And then the next homework, I think, is going to be like a web proxy or something. It's basically the same idea. Okay, see you on Friday.